Alpha 20-watt engraving and cutting solutions for your business. It says so right there on the box. So this Shenzhen Algo, I believe, Technologies, I believe is the way you pronounce it, provided this to me to unbox, test, demonstrate, review, all that kind of good stuff, and that's what we're going to do. This is getting away from the mainstream main brands you hear about all the time, something a little bit different. We're going to see how well this is constructed and how well it works. So first thing you need to do is get this thing out of the box. Okay, one of the first things I find is there are boxes inside the box and a block of foam packing. So at this end, we have an air pump. That's for the air assist. And in this box, we have the laser. So take this one out, get rid of that one. So there we are. Alpha engraving and cutting solutions for your business. Get this popped open here. Okay, right on top, we have some type of card here that slides out. It says hello. And it's a thank you for trying the laser and all that kind of good stuff. We have a box with the manual inside it. A consumable package. This would be, this is some little goodies and stuff you can practice on, and we'll show that here pretty soon. And you get a larger piece of, looks like 3mm plywood, fairly flat, not warped too bad. We have some foam. Then we have all the parts and pieces here. We'll start laying these out on the table. Got some interesting looking feet on it. Here's a power supply, power cord, USB cable, hardware, little toolkit, a nice little plastic box, it's kind of cool. And we have some safety glasses, and I am really glad to see these are actually the right color for a blue diode laser. They need to be orange. Orange is the opposite of blue, and that really works at canceling out. I have some very, very good goggles that I wear over my prescription glasses. They are orange and they're made for the blue diode laser and that wavelength. So the next thing we have is obviously the front panel. This is steel, by the way, like a stamped and rolled steel. So then we've got some more, we got something hidden here. Can't forget this. This is the actual laser head. The cord is already attached to the axis, so don't just go yanking on that. We have a rod here, one side frame, and that is a very substantial stepper motor. That's way more substantial than what you normally see. A lot of this is pre-wired, so you're going to have to kind of be careful as you pick things up and take things out. As you can see, we're all attached here. Everything is attached. So with that said, I believe that's the end of everything in this box. So we'll get on to doing some assembly. Yeah, I've looked through the manual here somewhat, and the first part of it is the cautions and don't do this, don't do that, and don't use it underwater and that kind of crazy stuff. You got here, it shows you everything that comes with it, and the assembly is very, very detailed. You have color pictures, everything is shown real well. So I'm going to get my parts laid out here. We'll get this thing put together. Okay, the first step is to put on the left y-axis rail to the front, which has the motherboard. This would be the one with the limit switch on, a little cable, and there's a little cable tie there. You're going to have to remove. That's in there for packing and shipping. We'll get that out of the way so we don't forget. Then it's just a matter of putting these two corners together right here. And all the holes line perfectly up, just perfect. I'll get you a close-up here when I do the other side. They do give you alien wrenches to use. I prefer to use these drivers. It's 2.5 M&Ms if you're keeping score there on what to use. And it's 4mm by 12mm screws. There are 3 screws used on the corner. Yeah, I'll show you a little bit more detail on this corner. This is a side that will have the stepper motor, and that will go down here at the same end as the motherboard on the front. So that will slip in. You'll put a screw here, here, and here. Normally I don't tighten my screws up right away. I wait till I have everything in, but this is self-aligning. I mean, it just lines up absolutely perfect. Self-squaring, I don't need to worry about it being wonky. That's a technical term, by the way. Okay, next is a back panel assembly, and it's just you're just repeating what you did on the front. Same thing, mounts exactly the same way. Everything lines right up. It's a matter of putting the 3 screws in here and the 3 screws in back there. I turn this around with the front away from me just to make it a little bit easier for me to do this here. Lifting this up with your hand a little bit will actually make those holes self-align. Everything just drops right into place. And with that side done, move over here to this side. Again, just pick that up a little bit and everything just lines right up. And on to the next step. Okay, I got this upside down. I've got the front facing me here. You'll see you got a couple wires here. This is really self-explanatory because one's yellow, one's white. The sockets here on the motherboard, one's yellow, one's white. They are polarized so that they only go in one way. So if you're looking at this yellow one of them is kind of separate from the other 2, the way it's molded. That will go, the single one goes towards the outside. So you may need to give it just a little bit of a twist, and it just plugs right in. This one here is a multi-pin. It's got a little clippy thing right here. So it's just a matter of plugging that in and letting that clip up, if this was upright, or down as you're facing it here. There we go. It should go with no effort whatsoever. On this end, you will see you have a four-wire cable. This has a couple little protrusions on it that will go away from the front of the stepper motor. Be very careful not to bend those pins. That should plug in just like that with no effort whatsoever. The next thing we're going to need to do is put the rod in between that drives the Y-axis. Okay, I flipped this back over so it's upright. I've got the motherboard facing me. The X-axis gantry, that's what this is right here, needs to mount to these mounting plates on each end. If you look at the end here, there are 2 holes that are already tapped, and they will line up with the holes in the end of the plate. And you'll use the 4mm by 12mm screws to put those in. That's these right here. You'll also notice there is another hole here. It's marked, it says tension. That's for tightening up your belt. So don't try to put a screw in there. It won't work. You need to use the far hole. And we'll talk about belt tension here in a few minutes. So it's exactly the same procedure on the other end. To get the hole lined up, just put your fingers under the stepper motor under there. Okay, this laser has limit switches, and here's one of them right here, which is a big plus. So, we need to plug this limit switch in, right here. It's black, it's a little 2-pin. You notice there's a thing here with red and black wire. It has that little clip on it that'll go down. It just plugs in like that. Next is to mount the laser head. You notice on the side here there's a lever. That tightens that dovetail up and loosens it. So if you drop that down, you can slide the laser head down into the dovetail, and I'm just going to set it at some random height here. And when you pull that up, it locks the laser head in place. And while you're up here, you have your air assist hose. That just simply plugs into that port right there. Okay, next up is the motor extension shaft, which I have clear at the other end of the table. That's this guy here. So you have the laser facing you, the motherboard here at the front. This rod is going to go in between the stepper motor over here and this rod over here. But before you put this in, you need to take your gantry here and push it all the way to the other end till it stops. Because you want everything to be aligned and straight and all that kind of good stuff. So you have couplings in here, which I need to try to get out. That's these guys here. You'll need 2 of them. You need 1 on each end. So you'll have it like this. That'll go in here, and then those couplings will slide over the shaft, so they are partway on the extension rod and partway on the stepper motor. So it will look like so. Again, you want to make sure you're all the way up there and everything's square. Then you can just tighten up those screws right there and make sure you're at a split distance so that half of the coupling is on each part of the shaft. Okay, these are, if you're using a driver, it's a 2 M&M screw. Okay, next we need to set belt tension. Okay, we'll start with the X gantry. As I mentioned before, there's a hole right here. It's even marked tension. Take one of these M4 by 12 screws, and I've noticed that from the factory, the tension on this belt on the X-axis is set perfect. So how tight is tight, how loose is loose, it's kind of subjective. You don't want it as tight as a guitar string, but you don't want the thing flopping around either. So this screw just goes in there. And since I'm already at a good point, I'm not going to tighten this any further. But if you were to tighten that down like that, it would make your belt tighter. Okay, at the back end of the laser, you also have some tension screws. I can get them out of the pack. Come on out of there. Okay, back here you'll see you have the same thing with tension. You'll have a socket head cap screw that looks like this. This is 3 M&M if you're keeping score. That will screw into there. Now on the side right here, it's another screw that you can loosen up to, or I should say lock your tension in. This here screw would be to pull it tighter or looser. Again, this is just perfect right from the factory. The other corner here will have the same thing. Put your cap head screw in there, your socket head screw in there, and you'll have this tension on the side. You can loosen up if you need to adjust your belt tension. But again, that side is set perfect from the factory. I don't even need to mess with it. I will put the screw in here so that I have it in there where it belongs. And I'm not cranking on it, I'm just so it's a little bit snug and won't fall out. So we can turn this thing back around. Okay, I'll show a couple things kind of close up here. This has a key which fits into the switch right here for on and off. So if you turn that off, take the key out, kids can't play with it. Emergency stop button up here. You need to stop in a hurry, hit that, it shuts it off. You can also bump that when you're working on something. I've done that many times. So if your laser suddenly stops working while you're messing around here, check that you didn't lean your arm on that. To release it, just turn it a little bit to the right, pops back up. I'll just set my key back here again. Okay, for focus, this has a lever right here you push down to focus off the surface of your material. Use this as an example. Let's say we want to focus on this piece of plywood here. We would push that lever down like that, release this here, let it drop down to that point, pull this back up to your focus. There's a little button right here, push it, and that pops back up out of the way. Moving on to the air assist portion of this, there's a quick start guide here about how to use it. And then here is your airline hose. Well, how'd they get that in there? There we go. A little cable tie there. We have the power supply, air volume control, and the air pump. Okay, for connecting the power supply and controller here for the air pump to the laser, there's a port on this side over here, which this DIN plug plugs into. It'll only plug in one way. It's keyed and it's pretty self-explanatory. And that will control your air pump, and there's up and down buttons here for the amount of volume you want to use. And we'll get into that when we get the laser started up. Next, you'll have the air hose. You need to make some connections. This end here will go onto the air pump. That just plugs on there like so. The other end of this, right here, will go to your airline. And I need to make sure I got the right amount of travel here. Push that all the way out to the max. See where that ends up. So my airline here actually ends up right inside this holder. So I obviously don't want this coupling to be inside that holder, so I'm just going to pop that out. And we'll run this underneath the laser. Now the way these connectors work is this just literally pushes in. And if you ever need to release it, you would push back on this flange and that will release the hose and you can pull it out. So it's just a matter, it's in like that, and that is good and tight. And I could cable tie that to, I'm not going to do that yet because I may add a baseboard to this laser, then it would be in the way. Okay, the power supply is pretty self-explanatory. You've got this plug here which plugs in right underneath where your air assist pump plugged in. Little port there for it. Of course, on the other end you have this cord to put on it, which we'll get to here when we go to start this up. Next you'll have your USB cable. This has a 90-degree USB-C on the end. That is the end that goes on the laser. That plugs in right above where your air pump plugged in. I know it's on the other side here of the camera, but it's all pretty self-explanatory. So what I need to do now is get a laptop over here so we can get this started up. Okay, ready for power up, and incidentally when you do plug it in, your air pump may come on, but you can use the controller right here to hit the minus button. You can turn it off. So we'll make sure emergency button is released. We'll turn this to on. Power button is going to come home. And it homed itself just like that. I have a honeycomb board under here to mostly to protect my saw table in case I decide to overburn something. So I'll get this in the LightBurn next. Okay, here we are in LightBurn, so I need to find my laser. And since I have so many, what I absolutely have to do is change this to choose before I try to identify this and have it find it. Otherwise it just won't. So go to find my laser, next. So there we are, 400 by 400 millimeter on COM6, add device. So we're going to call this the Algolaser. So I work in inches. 400 millimeters is roughly 15.75 inches. Just so you know. Put it next, and it auto homes, and we want it front left. That's correct. Finish. Okay. And go over here. Go down. Algolaser. It homes itself again, and we are all set. Now I need to make a couple little changes here. Edit. Device settings. Enable the laser fire button. And laser on when framing. Now when you go up here to the Move tab, I'll set my power very, very low. I'll set it at 1%. Then when I fire my laser, I get to see that beam. I'm going to turn it back off. So that's all there is to it, getting it in the LightBurn. Okay, so of course you're going to want to see this work. Well, first thing we need to do is test this. I've got a piece of scrap MDF in here I've done other tests on. It's kind of just a little test piece. Now I'm going to move this up so I can do my focus. Something to keep in mind is do not move any of these rapidly. So I need to drop my little focus thing down there, release this, set it back up, push the button there. Okay, I am now focused. So now I can go back to LightBurn and rehome the laser. And what should we make here? Well, just do a couple things with some text. I'm just going to do a line engrave here, just so it's quick. Okay, I am working from absolute coordinates, etc., and working from center, but I still want to frame this here just because it's a little scrap I just kind of thrown on here. I don't have a layout grid, so I'll set this and it'll frame right where it is going to engrave, and I'm going to move this a little bit so we're on some bare material. And I'm going to take this back home just to show how it will go up to its point. And then I'll just hit start. This is a 20-watt head. And I'm just doing a line engrave here, 1,000 millimeters per minute at 80% power. And there you can see what we got. So it comes out perfect, it's accurate. Now we'll do something a little more precise. Okay, what I'm going to do here is a turtle, mandala turtle, and it has a lot of very fine lines in it, and I'm going to crank the speed up here to 6,000 millimeters per minute. It's a line engrave, and I do have the air assist on. We'll get that started. Okay, so there it is, and this is very finely detailed. As you can see there's some fine details in that, and this did a good job. One thing I did notice though, and it's not the fault of the laser, it's because of where I have it. Now there are rubber feet on here, but my saw table is waxed and it is extremely slick. So I'll need to make a baseboard for this if I'm going to be using it on here to keep this from moving around when the laser's running at high speed. I noticed that when it started off on this right here, and I noticed the laser jumped a little bit, so I put my hand on it to keep it still. Again, it's not a fault of the laser, it's because of where I have it sitting. Yes, but will it cut? Well, you betcha it will. I'm going to back this out here a little bit. Put a piece of 1/8" plywood in here. I'll just slit that up. I'll have to move the head to set the focus on this one. Push my little lever down, drop that down, lock it, push the button, we're focused. Get this here centered more or less. I don't have a grid to work off of. I just hit my emergency stop. So I said you got to watch where you're putting your arm on there. You'll hit your stop and shut your laser off. So I'm going to burn a test grid on here with the air assist on. So let me get that loaded. I'm going to be running here as a power scale. I do this in all of my lasers, and I'm going to run this one in a large format so you'll be able to see a little bit better. Each one of my lasers, I run one of these on this particular material. It's 1/8 inch plywood, because we do quite a bit of things with 1/8 inch plywood. And even though this is a 20 watt and I can compare it to another 20 watt, they may not be exactly the same. That's why I run this test on every one of them. Just running a framing right here to make sure I'm within my area, and I should be. It's always a good idea to do that. Total burn time on this grid is 20 minutes and 39 seconds. Again, I'm working from absolute coordinates, job origin center. I've framed this already. Just hit start and let it go. Again, air assist is on. When this gets done running, I am going to look at fastening this cable down into these clips and seeing if I still have enough cable there for full travel. Right now the air assist line is in there and it seems to be okay, but I don't know how well that would work. I'll have to wait and try it out. It looks like the clips would be big enough to add that cable into it. So if you're new to this and I've never seen one of these before, this is a test grid to be able to establish what kind of settings you want to use for cutting. This is all at one pass, and I'll explain this in more detail. And I've also done a video on how to use this. And yes, I know you can also create one of these in LightBurn, but sometimes I like to do things custom, and this is custom. And after this gets done, we'll compare it to a couple other 20 watt lasers. Okay, so it has finished running its program. So what I do here on these is I just give them a tap. So if there's anything loose, it'll fall out. Well, a couple of them there didn't quite fall out, but they will. Just wedged in there a little bit. So what does this tell us? Well, it tells that 30% power and a 100 millimeters per minute, it makes a clean cut. I didn't push anything out of this. So that you can see some of these cut almost all the way through but didn't quite make it. I just go with the whatever falls out. So at maximum speed and power, if you went at 100% power, you could go at 600 millimeters per minute. So how does this compare to another 20 watt laser? Well, here's the Ortur LM3, and as you can see, it's pretty much identical. And this is the longer Ray 5, and again, pretty much identical, although this has had a lot of use. So that laser's had a lot of time put on it already. But this is something you need to do, not necessarily this big, but on a smaller scale to establish settings for what your project's going to be. There is no one setting for every laser that works every time. In fact, if I stack these where I put the Ortur over the top of the longer, you can see where the longer didn't quite cut some of these, but that's because it has a lot of hours on it. We put the Algo on top of the Ortur, and you can see they're identical because they were both new. However, that doesn't mean that every 20 watt laser is going to cut the same. And you also need to run tests on different materials. This happens to all be off the same sheet of plywood. If I were to go to the home store and get another sheet of this 1/8 inch plywood, it may cut differently. I always run a test first. I'm going to see if I can't do a little something with this cable. I think that cable is actually supposed to be in there, and it just came out in shipping. So we're going to turn this around. I can pop that down in that clip. It can. Got to be careful not to smash my air hose. I'll make sure I've got enough travel all the way down. Looks like I do. Yep, that'll work fine. So that'll take care of that little problem. You want to make sure if you do this that that's all the way down in the clip and the clip isn't hanging down too far, or your limit switch stop will hit the bottom of those clips. So now I've got good clearance. Okay, we're good. Something to look out for. So there's how to put together the Algolaser 20 watt, how to set it up in LightBurn, run a couple quick tests here. There'll be some more videos on this coming up. I am going to make a baseboard for this, and probably design some kind of risers if I decide to ever use a roller with this. And yes, you can use a roller with this. You would just simply unplug the Y-axis stepper motor and plug that into your roller. That's the subject of a whole nother video. Again, this was provided to me by Algolaser to test demonstrate. This is what we've been doing here. There'll be a link in the description on where you can get a hold of one of these if you'd like to pick one up. So, which one's my favorite laser? People ask me that all the time. Which one's the best laser? The best laser is the one that works with no problems. I am not loyal to any one brand of laser. This makes 17 lasers now I have altogether, and I don't have any favorites. I do have certain ones designated for certain jobs because then I don't need to go through the setup. But the best laser is the one that works with no problems. So, thanks for watching. See you on the next one.